Okay, so today we're starting a brand new unit on rational expressions, and this is 7.1 equivalent rational expressions. So rational means that we're going to express these as ratios or decimals. Okay, so when the numerator and denominator of a fraction are integers, the fraction is a rational number. When the numerator and denominator of the fractions are polynomials, the fraction is a rational expression. So these are two examples of rational expressions here. Here we have a polynomial in the numerator and the denominator. Here we have a polynomial, but these have to be factored in order to solve it, but they're still rational expressions. Rational expressions cannot contain roots, and they cannot have variables as exponents. So this right here shows that this is not a rational expression, and that's not a rational expression for there either. Rational expressions are not defined for the values for the variable that make the denominator 0, because you can't divide something by 0. These are called non-permissible values. So in this expression, x plus 5 over x minus 3 is not defined for x equals 3, because 3 minus 3 would equal to 0. So x minus 3 is a non-permissible value for that expression. Okay. So that's the first thing we want to do. And you want to get into the habit of expressing the non-permissible values right off the hop, because sometimes people just get into solving the problem and they forget the non-permissible values. So for example 1, determine the non-permissible values for each expression. Okay, so for a, the first thing I'm going to do is I'm going to factor the denominator. And before I start, so there would be something else to do, but you would just want to start by expressing the non-permissible values. So x cannot equal negative 3, positive 3. Same thing with b, 3x plus 2. We're going to factor the denominator, and we're thinking, what are the factors of 16 that if I add or subtract them could give you 8? 4 seem to work okay. In pre-calculus, I think you'd be expected to express this as 3x plus 2 over x minus 4 squared. So x cannot equal 4. Pretty simple. So go into the check, and I'll give you the answers for the check here. Okay, in the next one what we'll be doing is we'll be using multiplication to write an equivalent form. So what you probably want to do to make things easier is pick something from the numerator and multiply it by that, because we're going to have two forms. One is a non-reduced form, and the other is a reduced form. So what we'll do here is, let's say we choose to multiply this by this part here, the x plus 5. Okay, so we'll just write out the original equation. And we decide to multiply it by x plus 5. Let's state our non-permissible value here and here. Okay, so this will be equal to x plus 5 squared times x minus 1 all over 2 times x minus 1 times x plus 5. Okay, so here we see that this is an equivalent fraction because we multiplied it by the same binomial. So this is our first equivalent fraction of a. Okay. In our b equivalent fraction, we're going to just reduce what we have here. So in our second equivalent fraction, we can cancel like binomials in the numerator and the denominator. So 2x minus 1, x plus 5. We can get rid of this x plus 1 here, get rid of this x plus 5 there. So that's just going to be equal to x plus 2 over 2. Okay, go to page 215 and try the two equivalent fractions there. Now, the thing about writing equivalent forms here is you could have had, several different formats if you multiplied it by x minus 5 or x minus 4. So if you struggle with this one a little bit, just check the solution in your work text, and we can also talk about it in class tomorrow. Okay, let's go to the last one, which is write each rational expression in simplest form. So here you're just basically reducing. These are just reductions, and I think the trickiest part of this is just to, go to the solutions right away, is just to remember to talk about the non-permissible values. So we take a look at this one. First thing you want to do is get into the habit of expressing the non-permissible values. So here A and B cannot equal 0. So I don't mind if you work off here, but I'll just rewrite this. When we think about the 5s can be divided into both those. So that's negative 5 over 7. Here we've got a cubed and a, so it's a cubed minus a to the first, which gives you a squared on top. This has b squared, b to the fifth, so 5 minus 2 would be b cubed. And then c stands by itself. There's your answer. This one, you know what, you guys? I'm going to leave this one because you're going to do this one in your check. Because it's fairly simple. Here, we're going to factor. So, now here's a hint. If you factor the numerator, you can be pretty sure that in the denominator there's going to be an x minus 7 or an x plus 7. Otherwise, we wouldn't ask that question. X times x, I look at here with the factors of 14, that could give you 5, 7, and 2. And because this is a negative, make that a plus. Now we can talk about our non-permissible values. X cannot equal negative 2 or positive, or positive 7. That's a comma. My tablet's skipping a little bit today. Where can we cancel? Common binomials here. So that's going to be equal to x plus 7 and x plus 2. And for our last one, for D, again, we've got a factoring thing going on here. So we need to factor top part. This is going to be 2x times x. And this is going to be 3, so that's going to be 3 and 1. And because this is a negative 5, this should be a negative, and that's a positive. Now, I'm going to teach you something here called the negative flip trick. Negative flip trick. It'll help you to cancel. Okay. When we factor this, it's 3 minus x and 3 plus x. But here's the problem. Positive 3, negative x, positive x. So what I'm going to do is I'm going to factor out a negative 1 in this denominator and change it a little bit. So let's put a negative out here, which now makes this a negative 3 and a positive x. X minus 3, x minus 3. So it makes them identical. So I cross those two out. And let's talk about our non-permissible values. So x cannot equal negative 3 and positive 3. So once those are canceled, what we'll do is we'll just write our equivalent fraction here, 2x plus 1 over negative x plus 3. So it makes it a lot simpler. Okay. Try the check on 216.